Hello, in this video we're going to go through another way to kind of help you remember your special triangles. If you remember in the last video I did that larger diagram and I figured out all these values, which is actually an interesting problem unto itself, but some students find that a lot to do, and there are lots of ways to remember these ratios. One thing I'd like to say is you should at this point have memorized what sine of 30 degrees is. Make it like a game, and it sounds silly, but walk up to your friends in your class and just say sine of 30 degrees, and they should say 1/2. If you memorize that one, you can come up with your special triangle very quickly. In fact, you should have your calculator for a lot of your problems. You should have your calculator, so you can always cross-check that. So this is another way to remember your special triangles. This was one that I think a student actually gave me this one, which I quite liked. So what you do is you draw an equilateral triangle, and you write on each side of the equilateral triangle, you give it a length of 2, 2, and 2, right? So then what you do is you draw in you bisect that angle. Well, we know with an equilateral triangle that each angle is going to be 60 degrees, 60 degrees. And if we bisect this one, this is going to be 30 degrees, and this is going to be 30 degrees. So we also have to then note that if the length from here to here is 2, the length from here to here is 1, and this is 1. And just kind of, okay? I'm going to say this whole length here to here is 2. So then, now that you have this, you have enough that you could use Pythagoras' theorem to find the value here. So if you had to, you could say, well, this value here, let's call this x. So x squared is equal to 2 squared minus 1 squared, so x is equal to the square root of 3. So that's root 3, and then now you have all your information you need for your 30, 60, 90 triangle. So if we were to do this, we know that sine of 30 degrees is equal to 1/2. Cos of 30 degrees is equal to root 3 over 2. And tan of 30 degrees is equal to 1 over root 3. And then I can say sine of 60 degrees is equal to root 3 over 2. Cos of 60 degrees is equal to 1 over 2. And tan of 60 degrees is equal to root 3 over 1. And we could just write this as root 3, of course. And actually, let's just erase. There we go. Just write that as root 3. So that's another way to remember your 30, 60, 90 triangle. It's a nice little quick way. Remember, and I keep repeating myself, and I apologize if I sound like a broken record, you should have memorized sine of 30 degrees is 1/2. And again, it sounds silly, and I know my students laugh when I say this, but just ask each other those random questions. Asking yourself little simple questions all the time is the best way to go. If you ever get stuck in a question, ask yourself a simple question, and those little ideas will build up to more complex understandings. Now I'm going to stop here before I ramble off into some tangent. Okay, so let's do our second special triangle that we definitely need to know, and that's a 45, 45, 90. So with the 45, 45, 90, again, the fact that I kind of grab onto is that, remember, students often learn that, across from the 90-degree angle is the longest side, the hypotenuse. But what students often don't learn is that largest angle, largest side, but it also says smallest angle, smallest side, middle angle, middle side. So if this angle here, 45 degrees, is equal to this angle here, 45 degrees, then we know this is an isosceles triangle. I can put whatever values I want here as long as they're equal, right? So I'll put 1 and 1. I could put 100 and 100. It's going to make your ratio turn out to be a fraction that can be reduced. But if I put 1 and 1, and then I can use Pythagoras' theorem and work this out to get root 2, right? So therefore, sine of 45 degrees is equal to 1 over root 2. Cos of 45 degrees is equal to 1 over root 2, and tan of 45 degrees is equal to 1. And one thing I've said already is that sometimes students have already learned these and they'll say, wait a second, I've learned that sine of 45 degrees is root 2 over 2. Why are you writing 1 over root 2? And this is actually, if you're using stock textbooks, they'll often rationalize the denominator, which means get rid of the root in the denominator. So let's make sure we understand how we get this. This is another skill, but if you understand the idea that if with a fraction, whatever I do to the denominator, I can do to the numerator. If it's all multiplied by the same thing. So if I have sine of 45 degrees is 1 over root 2, I can go and multiply by root 2 over root 2. And that's all I'm doing. So then that becomes root 2 over 2. And that's the same thing for cos of 45 degrees. It's equal to root 2 over 2. Okay, so I hope this video helped. If you have other ways of remembering these primary trig ratios for these special, if you have other ways of remembering the primary trig ratios for these special triangles, share them. Lots of different ways, and different students require different techniques to make it stick. So yeah, and please feel free to share your ideas with me and ask any questions you want. Have a great day.